The new context of phylogenetic perspective was so dramatic, I'm not even sure I can summarize it. In 1990, when I went to my first scientific conference to present a poster, almost no papers, no presentations, no posters included phylogenetic diagrams. By 2 years later, all of them did. In tandem with that was a set of insights about extinction that had been rumbling since the 80s and had now started to become standard discussion. The distinction between background extinction, which is going on all the time, that instead of extinction being a one-off event for a failed creature, it turns out to be the ordinary event for any creature. And then add to that the somewhat disturbing concept of mass extinctions, phenomenal die-offs that nail potentially almost every single creature on the planet in the most extreme cases. These phenomena gave rise to the idea that there may be effects on populations, in fact on whole swaths of populations of different creatures, that happen at a scale well above anything selection on individual reproductive success could possibly address. The science of scales started to become a big deal in biology. That you could say there are causal variables occurring at a particular time and at a scale, that there are causal phenomena occurring across huge units of time, huge units of space, and then drop down in those units and you would see a completely different profile of causes. And you could do this for any level of biology, such that the variables you were looking at a particular scale could be acted upon from below, the way people usually think about it, from above, and you can't really tell which is which just by looking at the trait itself. The concept of punctuation, or its specific case of punctuated equilibrium, really wasn't all that important as its own thing, but as a representative of thinking about change at this level, at these scales, in the first place.